Okay, so when you have 5i plus 3i, you just add the coefficients and you actually get 8i. Okay, so there is a rule that anytime you have I squared, by definition, that would be -1 times -1, because that's I times I. And so since those are doubles, you actually get -1. So anytime you have I squared, you need to substitute -1. You cannot leave negative I squared in your answer. Okay, substitute. All right, so a complex number actually has two parts. So a complex number is usually in the form a plus bi. The a is the real part, kind of like what you've always been using, like 5. And the imaginary part is really obvious because it has an I next to it. So if you are given 2 plus 5i, the real part is the 2, and the imaginary part is the 5i. That's it. So that's just called a complex number because it's made up of two different types of numbers, okay? All right, so let's look at example number 1, and we're just doing some operations. So we want to do 6 plus 5i plus 4 minus 8i. So when we're adding, remember, you just want to add the real parts, and then we'll add the imaginary parts. So 6 plus 4 is 10, and then we want to add the imaginary parts using their signs. So 5 plus -8i, or 5 minus 8, is -3i. Okay, and then we can't simplify that any further. All right, when we multiply, this is going to take a little longer. So we're still going to do the FOIL. So you're going to do 5 times 3, which is 15. Then I do 5 times -9i. So 5 times -9 is -45. And just like we did with the x, we just put the I with it. Okay? So then I'm going to do 2i times both. So 2i times 3, well, 2 times 3 is positive 6 with an I. And then it's the last term that's going to be the hardest to remember. So 2 times -9 is -18. I times I is I squared. Okay? So that's the part that you need to have. If you have two i's being multiplied, you write I squared. So we have 15. And then these are both i's, so we can combine them. So -45 plus 6 is -39i. This is where it gets tricky. Remember, I squared. Anytime I see that, we can substitute -1, and those are being multiplied. So -18 times -1 is positive 18. Okay? And then these whole numbers we can add together. So 15 plus 18 is 33. The -39i just gets brought down. All right, you might want to rewatch that if you're a little confused. Okay, so for square roots, remember, we want to look for doubles. So I can think of this as -1 times 25. And then 25 breaks down into 5 times 5. So this is a double. It comes out. When you had the square root of -1, remember that was I. We don't have any singles left, so we actually don't have a root in our answer. All right, but let's look at example number 4. So same thing. I can think of that as -1 times 216. And then I want to break down 216. So that's a pretty large number. It's even, so I would divide it by 2. So if we do, we get 108. Okay? And you want to keep breaking that down until you can't anymore. So same thing. That's kind of a big number. We get 54. So the 2 stays, this 2 stays, and then 54 is 6 times 9. Or you could have done 2 again. 2 stays, 2 stays, 6 is 3 times 2, and then 9 is 3 times 3. Okay? It's still a square root, so you're still looking for doubles. So here's a double. Here's a double. And then single singles. Remember, we also had this -1, which is I. That goes on the outside. So I had the 2 and the 3. So we're going to multiply that back together. 2 times 3 is 6i. And then inside we multiply 3 times 2 is 6. Okay? So we broke down radicals last, and we're just doing it again with imaginary numbers. Okay, so go ahead and pause the video. I give you 3 to try. Okay? Look back at the examples, rewatch the video, you can rewind it and see how you do. Okay, so now you are done with Unit 2 lab. You can turn this into the office, or you can continue on with Lab 3. Now, Lab 3 does have 4 sections to it, so it will take you at least an hour to do, I think. All right, just to give you an idea. Okay, so if you're ready for this, we are going to do factoring. So factoring will be used throughout the rest of this course, Secondary 2, and it's used in Secondary 3 a lot as well. So the first type is called common factoring. So what is a common factor? It's basically a term, and it's really the largest, that can be divided by all terms evenly. Okay? So, I can't really compare this to anything you've done before in math. It's kind of like greatest common factor back when you did probably in 7th and 8th grade. Okay? So, tips for common factoring is you want to treat the numbers and the letters separately. Okay? They look like one thing, but they're actually different ideas, okay? So for the numbers, you want to, if you don't know the biggest number, or I'm going to say find the biggest number that divides into both, okay? If you're not sure, you can always do factors, and I'll show you that on an example. For the letters, it's always going to be the lowest exponent, okay? All right, I've got 3 examples though. So let's look at the first thing. First thing, a term is separated by a plus or minus. So 24x to the 4th is one term, and 20x to the 9th is your second term. So I want to find the biggest factor, okay? If you don't find the biggest factor, then you'll have to do this again. So let's look at the numbers. I've got 24 and 20, and what you want to think of is what's the biggest number that divides into 24 and it divides into 20? Well, I know they both divide by 2, and then I just try thinking of, well, is there a bigger number though? Well, think. 20 is 4 times 5, and so I think, okay, well, does 5 go into 24? No. Does 4 go into 24? Yes. So 4 is going to be our biggest. If you weren't sure, I could actually do my factoring, but I have to do both of them. So 24 is 6 times 4. So 2 times 3, 2 times 2. And then you just look at what they have in common. They both have a 2, they both have another 2, and that's it. So that's also how I would get it if I wasn't sure. Then I look at the letters. So I want to find the smallest exponent. So I have x to the 4th and x to the 9th. So the smallest is x to the 4th. And so that's my common factor. You do want to write it on the outside of a parenthesis. What we're really doing is reverse distributing. Since that's my common factor, what's really happening is you're dividing both terms by that common factor. Okay? So 24 divided by that 4 is 6. And then I want to take 4 x's out of both terms, so I don't have any x's left. And then 20 divided by 4 is 5. And I want to take 4 of those out of the 9 x's. So if I take 4 of them out, I get 5. So I have x to the 5th. Okay? And we look, do 6 and 5x to the 5th have anything in common? The answer is no. They can't divide by anything else that's the same. So you're done. Okay? So you should have something on the outside, your common factor, and then the same amount of terms on the inside, but they should be smaller. All right, let's look at example number 2. So that's all one term. It has a lot of things in it though. And this is all one term. So don't get overwhelmed. Let's look at 18 and 36. So I know 18, I would start with the smaller number. Well, that's 9 times 2. And so if you broke it up into 9 times 2, I would ask myself, well, does 9 divide into 36? Yes. Does 2? And the answer is yes. But let's keep going. That's 3 times 3, and then that's 2. 36, I can think of as 6 times 6, and so that's 2 times 3, 2 times 3. So they both have a 3, they both have another 3, and they both have a 2. So if we multiply that all together, that'll tell you your common factor. 3 times 3 times 2 is 18. 18 is the biggest number, okay? Let's look at our a's. If there's not an exponent here, there is like a 1. So I have a to the 4th and a to the 1. So a to the 1 is our smallest. This one has a b, this one doesn't, so I actually can't take any b's out. That's okay. C to the 5th, c to the 3rd, 3 is the smallest. So that would be my common factor. So I'm going to write that under both terms to remind me that I'm actually taking that out by dividing or subtracting the letters from both. So 18 divided by 18 cancels. I take one of those a's out, so I'm left with 3. I can't take any b's out, so I have all 18, and I want to take 3 of those c's out. So if I subtract 3, I get 2 left. The plus stays. 36 divided by 18 is 2. Take both the a's cancel because I am taking one out, and I want to take all 3 of those out. So I don't have any c's either. So that's it, okay? All right, let's try the last one. So this time, that's a term, that's a term, and that's a term. So we have 3 terms this time. So I want to look at 12, 24, and 36. And actually, they all divide by 12. I've got A3, A4, A6. So A3, H7, H10, H15. So H7. So 12A3, H7, 12A3, H7, 12A3, H7. Okay, so 12 divided by 12 is just 1. Take all 3 A's out, all 7 A's. So everything actually cancels. I can't write 0. The same thing divided by the same thing is 1. You need a placeholder. Minus 12 divides by 24 2 times. Take 3 of those A's out, so I'm left with 1, and take 7 of those A's out, so I'm left with 3. Plus 36 divided by 12, take 3 of those out, so I'm left with 3, and take 7 of those out, so we're left with 8. So this would be our final answer. All right, and nothing should be in common with all 3 terms. 1 really makes it pretty obvious. Nothing else will be in common. So I'm going to give you 2 to try on your own. This one doesn't have any numbers, but this one does. So go ahead and pause the video and try those 2 problems.